Hi, I'm Matthew, and today we're going to talk about how to run batch prediction using Oumi. So let's hop into things. You may have seen a previous video that I made about how to run online inference or interactive inference using Oumi, and this video is going to dovetail with it nicely. If you haven't watched that video, I do highly suggest it to understand the inference configuration and what's required there. I'm not going to go in depth in terms of what the actual inference configuration is in this video. So if you're curious, you can either check out that previous video I mentioned or check out our documentation. That's oumi.ai/docs. There'll be more information there. But to keep this video, relatively short, I want to make sure we can actually walk through the batch inference, So let's get started. What I've done here too is I have created a Python script that will actually help us get set up. Now, when you want to run bulk inference or batch inference, you obviously need to have some sort of data that you want to run bulk inference on. So I've written a Python script to help us with that here. Now, this script specifically is going to actually read one of our data sets. In this case, we're going to read the alpaca clean data set, and then we're going to write the results to disk. What you'll notice is the alpaca clean dataset is actually, in conversation format. The final conversation in this dataset is actually going to be the model's response to use for pre-training. We do not want that in our case, so for the sake of this example, we're going to read our entire dataset, and we're going to just go ahead and drop the last message because this is the response from the model, and we actually want to use our models to predict that final response. So let's go ahead and run this. I've popped open our Python terminal here. We can just do bulk infer, and let's do save conversations for dataset. Our output path we'll just say is dataset.json, and let's do num samples. Let's just do 10, or excuse me, we'll do 5 for this example, just to make sure things run in a good amount of time. And let's generate it. All right, great. So we should now have a dataset.json file. Let me pop that open. And we can see this is our conversation format. I'll just zoom in a little bit so you can see here. We're not too worried about actually what this looks like, but we are good to go. This is what we would expect. And let's hop into actually running inference. All right, so as you've seen in the previous videos, to run inference, we simply need inference configs, and we have 2 configs I'm going to use today. I'm going to demonstrate how to do this for a local model. We're going to use SmolLM, which is what I used in the Oumi training video, and we're also going to use Anthropic's Claude 3.7 model as well. So first, we'll start with our SmolLM. SmolLM, we have the configuration here. I'll just put this here so you can actually take a look at what it is. Once again, this will be included with the repository of code. I'll share the code I'm using in this tutorial down in the description below. But let's give it a shot. So in our terminal, we're going to run Oumi inference, and what that's going to look like is Oumi infer -c. Let's specify our config. We're going to do the SmolLM, and we're going to make sure we set our input path. Our input path is going to be equal to our dataset. So this is going to be dataset.json. And our output path is going to be equal to, we'll just call it SmolLM.json. And let's go ahead and start running. Now this may take a second, depending if you have the model prefetched or not. But it's only 5 examples, so I'd expect this to complete fairly quickly. And we are done. Cool. And we can see now too, we have SmolLM.json. We have 5 samples with outputs that we'll take a look at in a second. Now, just so we can compare things, let's go ahead and actually run this once again. We're going to run inference again this time on Anthropic. Actually, before I hop into that, let me show you the config. So the config for calling Claude Sonnet is fairly simple. We're going to specify that we want to call the Sonnet 3.7 model for Claude using the Anthropic engine, and we're going to set a politeness policy here. This is just so I don't have to worry about any rate limiting. The politeness policy specifically means that for each worker, in this case the default is 1, so there's 1 worker, wait this many seconds before making a second request. So, because we are going to make 5 requests, this is 5 rows, we're going to wait 0.5 seconds between each, so we expect this to take 2.5 seconds plus however long inference by itself would usually take. All right, let's go ahead and let's run this. So we're going to do Oumi infer -c again. We're going to do our inference config. This is going to be our Claude config. Our input path is going to be our actual dataset.json. And our output path is going to be, we'll just call this Claude.json. And let's run it. So we expect this to take the order of a few seconds, not very long, because it really depends on how rate limited I am, but we should see these come through pretty fast. And we are good to go. Perfect. Now, one thing you'll notice here, it mentions saving conversations. When you're using a remote engine, specifically here I'm using an engine that is backed by a remote API, Oumi does something nice and actually caches these results for you. The reason being, we don't want you to run like a bulk job where we're running all of these requests against an API that costs money, and halfway through maybe you hit your quota or something dies, your network goes down. We want to make sure all those results are saved. So you notice in the directory that I was running, there is a Scratch directory that was now created. This Scratch directory will contain a working copy of my predictions as I am running them. You'll see here that we have Claude.json, and this actually has the 5 predictions that I was making. Now, I didn't want to save in a Scratch directory, and so of course the actual output file here, Claude.json, is the one that I want. This is the final file. But say something had gone wrong halfway through and only 2 of these completed, 3 of them errored out, the Scratch directory would contain our works. That way you don't lose, you weren't throwing money away for any requests that failed. Okay, excellent. So we have now run inference against both the Claude API, or excuse me, against Claude through Anthropic's API, as well as SmolLM locally, and we can actually take a look and compare the results between the two. So what I've done is inside of this script is I wrote a quick little script to compare things. Let me move this over here so you can see. What we're going to do is we're going to say, given a list of files, we're going to just actually print out the rows for these files so you can compare how different models, how different models worked for different pieces of our data set. So let's take a quick look. We'll zoom in here on our Python pieces and let's go. All right, so if we do bulk infer, let's compare predictions, and let's compare predictions for SmolLM.json and what do we call this? Claude.json. And then we can choose which prediction we want to compare. Let's compare the question at index 1, so our second question, and see how they looked. All right, so first we're going to show the results from SmolLM. All right, so the input prompt, we see, okay, we have our system instruction. The question is, what are the 3 primary colors? SmolLM is quite verbose. It says red, blue, and yellow with a lot of extra text around. Looks like we hit our token limit based on our inference config. Seems reasonable. And now we can look at Claude's response because we're going to load from Anthropic, or excuse me, from Claude.json. We can see, again, same prompt here. What are the 3 primary colors? Claude's response is much more terse, which is to be expected, but this is good. We can look at one more just to make sure things look like we expect. The question in this case is give 3 tips for staying healthy. We see this is from SmolLM. SmolLM says, okay, maintain a balanced diet, stay active, get enough sleep. Sounds reasonable. Listen to the response from Claude now. Maintain a balanced diet, exercise regularly, prioritize sleep. Okay, seems pretty good. So what we've done so far is we have run bulk prediction. In this case, I'm not going to necessarily call it batch prediction, because what we've done is we've run online inference using the online inference API for all of these APIs, just in a serialized manner where you specified a file and we ran online inference for each element of that file. Not every API provider has a batch inference API, but for those that do, a lot of them have implemented OpenAI's batch API. And if you want to use it, we actually have a way to do that. So we'll hop to that next, but I want to point out that actual batch inference, it depends on the inference provider, and so we've implemented one for OpenAI, but not other providers at the moment. What this means is if you want to use it, it's not a first-party available solution in our command line interface right now, but it is available through our Python API. I've broken this out in this Python file that I'll share with you, but it again is only available through the Oumi Python API, but I'll walk you through exactly what that looks like. All right, so let's take a look. So to run batch inference in Oumi, you just need to do a few things. Under the hood, we're actually instantiating inference engines when we're actually running these pieces. I covered that in my last video. If you're unfamiliar, please take a look there. So to run batch inference, we're going to create an inference configuration. We're going to specify the model we want to talk to. In this case, we're going to now talk to the OpenAI API, and we're going to talk to the GPT-4o mini model. And we're going to specify a parameter for batch prediction that's specific to them, specifically that batch prediction completion window. This is how long is it going to take for batch prediction to complete, or how long is it acceptable for this to take. We'll say 24 hours. We don't really care too much. Obviously, for the sake of this video, I do hope it takes less, but we have a way of viewing it otherwise. Once we've created our config, we're going to instantiate an inference engine. Inference engine is what we use under the hood for all of our inference pieces, and this is what we're going to use for batch prediction as well. So we'll pass in our model parameters, that's our configuration.model, and our remote parameters. So that's the configuration.remote params that we instantiated up above. And to prepare, what we're going to do is we're going to use the exact same data set. We're just going to read the conversations, and then we are going to run what's called batch inference or infer batch. This is actually an API specific to inference engines that are based on the remote inference engines. And this is going to return us a batch ID that then we can pull and check to see how it works. So let's give this a run, and then we'll run through actually pulling this so we can take a look at how batch prediction is working end to end. All right, so the method we want to call here is going to be called run batch, and we need to pass in the file path. So we're going to do bulk infer dot run batch, and we're going to pass in dataset.json. Now this is going to kick off a bulk inference job on the OpenAI API. You don't see it here, but I have actually added my OpenAI API key just to make sure that we can actually talk to their API and run batch jobs like this. So let's get started. All right, great. We already have our ID. Now I have also written a script up above here for polling. What this is going to do is it's going to pull the batch API every 5 seconds and check to see the status. And when it's done, it'll print out our results and we're good to go. So let's give it a try. Let's go ahead and pull status. Oops, I need to make sure I'm doing this in the right namespace. So it's bulk infer. And we're going to pass in the ID, and we're going to pass in dataset.json just so we can read our original conversations again. All right, it looks like it's 80% done. This is going to pull every 5 seconds. Oh, and it's actually already complete. Great. Okay, so we only had to pull twice. Now, what's going to happen here is we're actually going to go through and print out the results of batch prediction. Just as an example here, you could download this as well. What we've done is we've actually called get batch results. This goes and gets the actual results from the batch API and OpenAI in this case, and aligns them with the input conversations. That way you can have the history of what was your input and what was your output. Now, what we looked at before was index 1, and I believe index 2. Yeah. So we can take a look to see what we get in terms of outputs. So we have a question here. Give the 3 tips for staying healthy. Okay, maintain a balanced diet, stay active, prioritize sleep. Looks good. What are the 3 primary colors? We have the answer. 3 primary colors are red, blue, and yellow. Great. And of course, it'll go on and on for the additional pieces we have inside this batch prediction that I didn't go over before. So that's as simple as it is to run batch prediction with Oumi. The main things to know is that if you want to run against an online API, again, this is not a batch API, use Oumi infer and specify an input path and an output path. An input path should be a set of conversations, and an output path is obviously where the results are going to be saved. To generate these inputs for using batch inference in this way, I highly recommend using an existing Oumi dataset or creating your own dataset, and then you can easily serialize this into a conversation that's uploadable to these endpoints. Now, if there is a batch endpoint that supports the OpenAI batch API, you can use our inference engines and our Python API. The key parts there, to recap, were instantiating an engine yourself. This is the OpenAI inference engine. And then making sure that once you've read your conversations, you call infer batch. Once you've called infer batch, you'll get a batch ID. You can pull it using get batch status, and you can actually read the results by calling engine.getBatchResults. And that's as simple as batch prediction is with Oumi. I want to reiterate again, this is a fantastic tool if you need to generate silver labels for data sets, or maybe generate additional insight. You have a large amount of data that you need to annotate, or just are doing a bulk job for your general work where you need to use a large language model to process data in some way, shape, or form. This is a simple way to do it with Oumi. That's been it for me today, folks. And once again, until next time, happy tuning.